This is the topic that I particularly like because this is one of the basic things that we do in my laboratory. That's why I like it. But I will try not to talk too long about that. So, there was a book once published in 1991, I guess, or let me check. Yeah, it was published in 1991. It's called Life's Little Instruction Book. It became immediately a bestseller because it's a book that contains very short advice phrases regarding how to live, what to do, what not to do. And there was one particular thing that I liked. The author, Sir Jackson Brown, said that, remember that the more you know, the less you fear, and that may be a motto for the radioactive waste management, especially for the radioactive waste characterization. The more you know, then the less you fear. So, in this presentation we're going to discuss if the waste characterization is needed or is it just a waste of time and money. Also, we will learn, I will tell you how we do characterization in Ukraine, for which purpose, how it's technically done, and just get you acquainted with some of the examples of what we have done already in Ukraine. So, let's refer one more time to the respected organization, International Atomic Energy Agency. They say that waste characterization is determination of physical, chemical, radiological properties of waste to establish the need for further adjustment, treatment or conditioning, or its suitability for further handling, processing, storage or disposal. So basically, this is the chemical, physical, radiological analysis or investigation of the radioactive waste to determine what to do with it. The cradle-to-grave scheme, provided also by the International Atomic Energy Agency, shows the way of the radioactive waste from its generation to disposal, or cradle to grave. It shows that after generation it should be pre-treated or minimized. If it's long-lived, then it should be treated, or just its physical and chemical properties are to be changed somehow, then it should be conditioned, put into passively safe form. Then it should be stored, go to storage or to disposal near surface, deep geological or any other type. If it's short-lived, then it should be put for decay for some time and then either discharged or put to landfill. I have a question. If the IAEA is very much supports the characterization, why don't they put the characterization anywhere? Where is characterization? No? Characterization is everywhere here. But at each stage you need to do some analysis, some measurements of what you do for a different purpose. Either to check the technology if everything goes okay, or what you have got from the generator, or what you put for storage or disposal, or if the storage for decay was done or you have to wait for some time. So characterization is basically embedded at every stage of the radioactive waste management. So among the advantages, of course, as any other procedure or process, waste characterization has advantages and disadvantages. Advantages are that first, you assure safety. You know what the radioactive waste contains, that's why it's safe. You make sure that it's safe. Quality and product, especially with regard to treatment or to conditioning of the radioactive waste. You have to do some measurements to make sure that what you get at the end of the process is up to the requirements that you have. Also for inventory and classification, you need to do some measurements, and to reduce the conservatism, especially this is with regard to disposal, because what you want to dispose of is becquerels and not the cubic meters. And decision making, to decide what to do about the waste, you need to know what you have to do with. Among disadvantages, characterization is expensive. And chemical, physical, and radiological analysis is expensive. And if you have to deal with something that you know is radioactive waste, it becomes 3 times more expensive. Then, sampling, representative sampling, is very, very difficult. If you don't do the right representative sampling, then characterization doesn't make sense. And also we feel that we don't have enough qualified personnel for that. Actually, that's almost everywhere. Maybe not in Japan, but in my country it's everywhere. So, what happens when there is no proper characterization? This is, personally, I like to show case studies that are based on malpractices, on bad practices, because something negative is easier to remember. So before 2015, and during the Soviet Union, and even after the independence of Ukraine, the approach to the radioactive waste was like that. You remember Margaret Mitchell? She wrote the novel Gone with the Wind, and there was Scarlett O'Hara who said, I can't think about that right now. If I do, I'll go crazy. I'll think about that tomorrow. That was the attitude to radioactive waste management. We generate something now, we put it and let us think tomorrow or the day after tomorrow, maybe in 30 years, or maybe some other people will think about that. As a result, we have a lot of radioactive waste accumulated at nuclear facilities on sites. I mean, we have historical radioactive waste with no history traceable. We have difficulties in radioactive waste management, safe disposal, conditioning and disposal. We have definitely difficulties with that. And what I would like to show you is that's a real case. Once we had there is one radioactive waste generator quite considerable in Ukraine. They have several storage facilities, and once they decided to do something about their solid radioactive waste, what they wanted to do actually was to retrieve it from one of the storage facilities, have it conditioned, because they had a conditioning facility, and probably dispose it. But before that, they needed to assess the amount of radioactive waste, the cost, and everything. So what they did, they sent us a request. A request was like this: can you please develop a procedure for or methodology for representative sampling of our waste? Then we will do the sampling according to your methodology. We will send the waste to you. You will do some measurements, and then we will make the estimates about the cost of the conditioning and for the handling. We said, of course, but we need to know some initial information. So how much waste you need there is that you want to tackle with? They say 1,100 cubic meters. 1,100 cubic meters is actually a lot, so representative sampling is kind of difficult. Okay, maybe total activity. Total activity is like that, which is not very much when divided among all those cubic meters. Okay, what about its radionuclide composition? We don't know this time. We think we may have some cesium-137, cobalt 60, and some other. At this point, we started feeling very apprehensive about the future work, because in terms of radioactivity, some other can mean really dangerous things. But we thought maybe they know the origin of the waste, maybe this will be easier. So where the waste comes from, we asked. We don't know, they say. We think it came from nuclear power plant operation, but we're not sure. If you will find some waste from Chernobyl accident, it's okay, we think it may happen there, but so this means all type of alpha, like. Okay, we said, maybe you know something about your waste. Maybe you know some other characteristic, because we want to develop a methodology for sampling. Do you know any other things? They say, yeah, we have mixture of radioactively contaminated pipes, pentanic resin, paper, sand, or clothes, blah blah blah, all this stuff in the world mixed in one storage facility between 1978 and 2003. Do you think it's possible to develop a methodology for representative sampling of 1,100 cubic meters of that? Yes, it's possible, but it will take a lot of time. Do you think it will cost a lot to do such analysis? Yes. Do you think they will have to spend a lot of time and money on the procedure that they want to do on this process? Yes, I think years. So you may think that this is a real case, it happens very often. But you may think that Ukraine is not very good example because it's a post-Soviet country, not very rich. But let's then take Belgium, for example. Belgium is the heart of European Union. They have very good facilities. One of them is Belga Process. It's very respected organization. They do all type of treatment and conditioning of waste. They have temporary storage. They dismantle obsolete nuclear facilities. Seems like they are very famous and they are trendsetters in this in Europe. But in spring 2013, they found out that part of the cemented waste that were put in drums, they lost their integrity due to corrosion. They found out that on the top of the cemented material, between the lid and the surface of material, there was a layer of gel. It was very, very aggressive, and it actually made the drums corrode. And they found out, they were very shocked by that. Well, how could that happen? But these pictures are just, for example, it's not. I didn't manage to get the real pictures from there, but I think it looks like that. So they found out that during their procedure, this technology of cementation, something went wrong, and the alkali that was present in radioactive waste reacted with the silica that was in the cement, and this gel was formed. As of November 2016, this problem remained unsolved. They just want to separate the corroded drums from those which are okay, put them separately and see what will happen. So, should they have a very good chemical analysis prior to conditioning, they will never have this situation. So, characterization is a very useful thing. Let's move to the waste characterization criteria. Criteria of characterization is simply parameters that you have to determine in the waste to describe it fully. We have 7 radiological criteria, which means like specific activity, total activity, surface contamination, etc. Chemical criteria like chemical composition, toxic substances, etc. Physical and thermal criteria like residual heat, porosity, mechanical strength, and any other things. And when you determine all of these criteria in one object, because it's impossible to apply all the criteria to one object, but the maximum applicable number of criteria to one to one object, that's enough to describe the object, and this means that you carry out full-scale waste characterization. And you should remember that if you see that this is banana, you should not do the DNA test. So characterization has to be reasonable. If there are some properties that you can name just off the cuff, then it's okay. No need for excessive characterization because this is expensive. Again, we refer to the IAEA. They offer to divide all types of waste into 4 groups with regard to the characterization that they require. Simple and variable, complex and variable, simple and stable, complex and stable waste. Here, simplicity and complexity refer to the number of criteria that you need to find out to determine for the waste to describe it fully. And variability and stability means if these properties change with time or remain stable. And with regard to that, you have different types of characterization. For example, let's take the waste from nuclear power plants. It's simple because you have certain procedures, certain processes during which they are formed. Of course, if we take the condition that nuclear power plants were operated normally in normal mode, so the waste from the radioactive waste from the nuclear power plants is simple because you can name all the part of the properties just off the cuff, knowing the technology where the processes during which they were formed, and it's stable because if everything is okay with the nuclear power plant, that you have the waste with certain properties today. You had them yesterday, you had them a year ago, and probably in 2 years, if everything is okay, you'll have the same waste with the same properties. And for that, you need to do characterization for safety and quality assurance, especially for conditioning facilities. So, how we do waste characterization in Ukraine since 2015? From the previous presentation, you probably know that things were not so good with the radioactive waste management in Ukraine, and of course our government knew that also. They have noticed something, and that's why they decided that it's maybe characterization that can set the situation, or at least improve those disadvantages that we had about those problems that we had about our national radioactive waste management program in pink, that I highlighted in pink. That's why they completed the Europaid project, improvement of the infrastructure for the radioactive waste management in the Chernobyl exclusion zone, phase 2 in 2015. This is the Chernobyl exclusion zone. This is the nearest zone, 10 kilometer zone close to the reactor, Chernobyl nuclear power plant. And here is Chernobyl actually. And in Chernobyl there is an ecocenter, and the ecocenter there is a laboratory, designated laboratory for characterization. It was established actually with the aim of reclassification of radioactive waste, so we expected that the radioactive waste will be reclassified for the new classification. So we are considered as an independent expert in radioactive waste characterization in Ukraine. We have several functions, among which are physical, chemical, and radiological characterization of Ukraine. We do it either directly or indirectly. We do measurements of environmental samples from exclusion zone within the framework of the schedule for monitoring. We also do verification of waste packages prior to disposal, develop the methodologies for characterization, training also, and also we offer the scientists to test their technology for radioactive waste treatment at our laboratory. So we act according to the principles. We have the base. We're not scientists. We're not researchers at the lab. We just measure. You have the ideas, come, and we're happy to make them true. The status is that we are independent designated laboratory for measurements in terms of characterization and monitoring. Our major objective is to protect future generations. So we are kind of very kind to future generations and like children. Analytical capacities. So we have full capacity to perform physical, chemical, radiological characterization because this laboratory was created keeping in mind those characterization criteria. And this is actually our analytical capacities. And with regard to radioactive waste, they make up around 10 to 30% of all samples that we have per year, of all, not samples, but measurements that we have per year. We have a set of stakeholders, and they're interested in wide variety of services that we can provide. For example, full-scale characterization is very interesting for radioactive waste producers and disposal facilities. Fundamental research, scientific institutions, yet sometimes they come to do some measurements. Consultancy is for regulator and state exclusion zone, state agency for exclusion zone management. Research for solving the problem of shelter dismantling. This is Chernobyl nuclear power plant sometimes asked to do some measurement. Analytical tool for international research, Ministry of Ecology and Ministry of Science. Development of methodologies interesting for regulator and other labs. Treatment technologies, prototype testing, just what I've mentioned, is interesting for scientists, for waste management organizations, etc. And also we provide some services in student training for universities and other labs. So now I'm going to show you technically how the characterization actually looks like, what it looks like. So step 1. What is step 1 in characterization? You have my lectures, yeah? That's gonna not be interesting. Okay, step 1 is preparation. Preparation is a necessary step because radioactive waste characterization is very expensive. So prior to bringing the samples in, we need to request initial information. Sometimes they cannot guarantee that they will give us a lot of information, like it was in case that I've told you about, but we request at least what do you want us to work with. Then we choose a development of program for characterization. A program is our in the document that is inside of the laboratory. Actually, it shows what to do. If you get this sample, you have to do this, this, and that. If you have this sample, you have to use this methodology. Just put it aside for 3 months, then take it out, etc. Then we choose the method, including sampling, because sometimes we're requested to do the sampling also. And we do modeling if necessary, because it happens that they want us to characterize the samples that we've never worked with. For example, we had one of the radioactive waste producers asked us to characterize their bituminized waste. We've never seen bituminized waste before, so we modeled it according to the information that they provided and tested if our instruments will work well with it. And also we do preparation to make sure that our equipment is ready to the future work, because there is the situation when the customer brings the sample to the exclusion zone, to the laboratory, and we say, oh, we're sorry, no, our spectrometers don't work, please take them back and bring in a month, probably we'll have an opportunity to do that. This is unacceptable. And we also don't want to store the samples simply because we don't want to store radioactive waste at the laboratory. So after we did step 1, after we prepared, then sampling. We have sampling. Sampling is one of the most difficult stages. Yes, this is not only technical difficult, but responsible, I would say. It can be performed either by Ecocenter or by the other organization, even the waste owner or some other organization, depending on that. Generally, we say either by Ecocenter or not by Ecocenter. In the Ecocenter, we have a special department for environmental control. They are responsible for sampling. They consist mostly of geologists. That's why they can do sampling perfectly of any type of objects. We have specific requirements to sampling. Mostly, we care about 2 things. About three. First is activity. We are class 2 laboratories, that's why we're limited in activity that we can work with. Second is package in which the radioactive waste comes. For example, if there is something that is leaching or just very much contaminated, that we do not accept it generally. Number 3 is size. Because the size of the sample, because if we need only 1 liter of water, of liquid radioactive waste to characterize it, and then they bring 10, then we give them 9 liters back, so we don't need it. And sampling can change the course of characterization because they can find out they need some other investigation for the investigation. And that's the next thing. Every sample that is taken or brought to the laboratory is issued a passport. In the passport, you have the number of the sample. Here, 10 means that it's something that is not environmental, means maybe radioactive waste also, not within the monitoring program. Then this is the type of the sample. This is the date when it was taken. But we also have electronic passport, but paper a must. Here's the sampling point, the depth, it was liquid. Here is the dose rate, and here's what they want us to measure. And here is the person who was responsible for sampling. And we highly recommend, if you ever happen to do sampling, please do take photos or videos, even it's better, because otherwise you will not be able to prove that you did everything correct. If you have some mistakes, you can look through the video again and again and find if you did anything wrong. And representative sampling is 50% of successful characterization. That's why if you did everything correct, then you are very lucky you are very likely to do everything correct during the next step. The next step is sample preparation. Sample preparation is needed. We do it at the laboratory because it's needed because sometimes samples arrive as very contaminated liquids with some solid objects inside. Then we prepare it into, you know what sample preparation is. There is no need to tell you so much about that, but the way we prepare samples for characterization, the way that we work with the waste is different from the way that we work with environmental samples. It's very different. And there is also a risk of cross-contamination because, of course, radioactive waste has a level of activity which is much higher, radioactive waste activity is much higher than the activity of environmental objects. That's why for sample preparation we have designated premises, designated tools, designated sometimes even personnel, etc. And if you do sample preparation very well, that you add another 40% to the success of characterization. So at the end, sample preparation means that you are very, very lucky to get a good result. Step 4 is actually measurements. We do radiation, physical, chemical properties. We do always parallel measurements. For monitoring, we do only one measurement because it's a very massive amount of samples, and we cannot afford it. It's not needed. But for the radioactive waste, we do 3 or 5 parallel samples or parallel measurements, and measuring of on-site during sampling is always preferable. If you can measure, for example, dissolved oxygen in the tank, because you should have a lot of portable equipment instead of bringing water in the laboratory. That is preferable, of course. So because measurement consists of so many elements like instrument, operator, consumables, procedure, it's very expensive, but it doesn't determine a lot really. Because if you did sampling and sample preparation wrong, then whatever good equipment you have, whatever good, brilliant apparatus you have, you will never get a result that will characterize the waste. Just you will get a figure and you may be very happy with it, but no one will be happy except for you. Step 5, data analysis and reporting. Calculation. The basic is calculations that take into account sampling and sample preparation. Calculations in this case of radioactive waste characterization is done by the laboratory. Also, we fill in the standard protocol. If the customer requires, we make a detailed report and we attach all the measurement files, all the photos, the videos, whatever they want. And here's the standard protocol. For example, we had number, the day when it was issued, what we did, the type of work, also the type of number of parameters that we measured, the method and the equipment, the result, and we also put permissible levels or maximum allowed concentration or whatever, and here we write conclusion. We can put, for example, results that were obtained by other laboratories if it's some expert measurement, but we never provide recommendations regarding waste. Be careful with that. If you say, like, we measured this and this and this, and we advise you to do this and this, then you immediately share the responsibilities for the future of this waste with your customer. You don't want it really. It's his waste. He must be responsible for that. You only say, we got 100. The permissible level is 1. It's 100 times more than the permissible level. That's it. It's up to you what to do. You may drink it, but we may also provide the name of the regulation that said it. It's his responsibility what he do with it. We only say the result. There is also step 6, which is very important. You have, after the analysis, you have to handle the residue of the sample and secondary waste. In the picture, what you see here are the samples of the radioactive waste, and here is the secondary waste. The same as you showed me, Aya Sensei, today. we have a lot of secondary radioactive waste, especially when we have some specific samples like water from the solution for after decontamination, gloves, and sometimes some laboratory hardware, etc., etc. We remove the residues of the leftovers only after our customer has accepted the report. If we make sure, are you satisfied with the report? Yes, please send the document. Yes, we remove the rest of the samples, because sometimes it may happen that the customer may say, "Oh, come on, I don't believe the results. There is something. No, it cannot be like that." Then we have to do analysis one more time, but we have to do with the same sample that we did sampling. We took with that particular sampling. If you have an opportunity to decontaminate it, you should decontaminate your equipment. If you don't have an opportunity, you just cannot decontaminate it. Just you have to dispose it, either dispose or return to the customer. Usually we use like this: here's your leftovers, here's your garbage, thank you very much. Because otherwise the radioactive waste, this characterization would be very much expensive, but usually our customers are disposal facilities, waste storage facilities, so they don't have so much trouble with handling secondary waste. Here are some examples from the past work. They were done since 2015, so like during 2 years. We once did the measurements of treatment in soil moisture and radiation accident conditions. There was some disposal facility who had a tank with the liquid radioactive waste, which was underground, which contained some radioactive waste with high level of tritium. And once they noted that the level dropped, they, of course, assumed that there was a leakage somewhere, but they didn't know where, at which side of the tank. We recommended them to take samples and bring to our laboratory. They did it. That was actually the boreholes. They took the soil from different depths, and we did measurements, and we determined the place around the tank where the concentration of tritium was the highest, where to search for the leakage. They did it. The most important thing was about this work was that we had to do the research and the measurements at the same time. Because for the measurements we had like 2 days, and we had to do in parallel the research not the research, but rather parallel measurements which were conducted according to our methodologies, and the standard methodologies is like 10 days. You need like 10 days for that to make the calculation correct and to see how much we lose or how much data we lose with that. Also, we did some independent radiological and chemical measurements of contaminated scrap metal. There was expert measurements. We were proud to have participated, and that was an assistant to State Border Gas Service of Ukraine, but I would say there was an assistant to the regulator. What was most important about this work is that we not only did the measurements of the scrap metal the situation was like that. The scrap metal was to be taken abroad, to sold abroad, and some laboratory found out it was very much contaminated. So we did expert measurements. We not only did the measurements, but we also analyzed the methodology and the reports done by that organization, and we found out where they had mistakes, and we showed them, you do this incorrect, and this incorrect, and something is unrepresentative. So that was also very remarkable work. And regarding the Soviet army military activities and those uncounted amount of radioactive waste, there was some site in Ukraine, and there was a NATO project for decommissioning of the site. We did characterization, we investigated everything on Earth. That time I can't remember if we did recommendation. I guess for water we did some recommendations because we performed the sampling ourselves, so we were sure about that. And we also had videos and all the pictures. That's why that was easy for us. We investigated different media. We characterized the site, and we many reports, but it was a very unusual and successful experience for us. And also, what we are particularly proud about, I'm not sure if you have these handouts, Emi-san, do they? So we performed last year a summer school on waste characterization and radiation environmental measurements. The students from universities in Poland, they actually spent 2 weeks, one in the field. They did sampling, field measurements, etc. And then they brought the samples to the laboratory and worked with the real radioactive samples. Some of them were radioactive wastes. They could very much improve their master thesis, and they got consultation. They were very, very happy. We plan to perform it this year also. So if you want, you may apply also. So, conclusions. Waste characterization fosters waste management culture. If you do some measurements, that you will probably not mix all the types of radioactive waste in one storage facility. If you invest money into characterization, you must be more careful about your waste. Every dollar invested in characterization saves hundreds of dollars at later stages of radioactive waste management. Remember the Belga process. If you do proper measurements at the beginning, at the end of the cycle for radioactive waste, you will be sure of what you're disposing. And of course, there are some very, very complicated cases of characterization when there is no initial information, but if we perform good joint research, if we share our practices with other organizations and other organizations share the practices with us, if we train the personnel or just educate the personnel or foster the personnel from the very beginning ourselves, then we will do everything successfully, even in the most difficult cases. Thank you very much. If you have any questions, I will be very happy to answer.